However, we can control a certain level. Okay? How the DBMS store the data. Okay? Internal view of the data. Internal structure of the data. For what? Performance. For better performance, in other words, speed, so we can little bit control such a design. That's called the practical database design. Another way to get better performance when you are using the DBMS database is SQL. Select from where. Sometimes by changing just the order of the table. For example, select column name from A table, B table, C table, where condition. It takes 7 days. Actually, I never wait, so 7 days. Forever. It takes forever. Okay? But by changing the order of this one, C and B, it will take 0.001 second, 1,000 second. How? That is the tuning, especially SQL tuning. Okay? So even though you are using the same database, but depending on how to use your SQL, it's a totally different performance. This is called the SQL tuning. SQL tuning is not easy. It depends on sometimes the data. It works very well, so 1 second response time. 1 year later, it will be 1 hour. It takes 1 hour. Why? Simply more data you have, right? The more data you have, the longer time the SQL takes. Okay? Then how can we speed up such a query? That is the problem of the tuning, especially SQL tuning. Also, on the other hand, you can tune up your system in terms of administrator job, parameter area, and the reserved area. Like the Unix administrator keep monitoring their system and try to kill the zombie process. Also, if we have the full capacity of the system, we can add physically the new resource, like adding the CPU or memory, or sometimes we can use cloud system, dynamically changing the resource allocation, something like that. So that is the tuning power. In this class, we are not going to cover the details of that, just overview of the practical database design and tuning. Probably handout in the second class or second week, you may get the diagram of the database design process. Okay, so this part is for data analysis, right? Design and conceptual modeling and physical design, then eventually make the database. And also this part is for application analysis. Can you remember that? So sometimes we have used the result of this one for application analysis. From time to time, we need the input from the output of the application analysis. It's very, very important when you are doing the practical database design. For example, in Lec15 case, my database is only for read-only. There's no update, there's no delete, okay? In that case, so first, how do you know my database is a read-only database? My database system is a read-only database. You can check application program, whether you have update command, whether you have delete, whether you have update, insert. Insert, yes, but no update, no insert, no delete. Only select, which means your database is read-only database. At that time, you don't have to worry about update. You don't have to worry about any deletion. Just focusing on the performance of select, retrieve the data at that time. For example, we learned about what is an index. What is an index? Index is another data structure of this one, which means there might be the block, okay? Physical data block in your hard disk drive. It can be file, it can be raw device, it can be block based, okay? And also you have, this is an index, this is the data. So how can you access the data from select, from employee, where employee ID, actually to explain this one, it will take a couple of hours. Okay? But I like to simplify. What is this? Triangle. What is that? Whoever take my course before?
Yeah, it's a computer.
What is this? It's a computer. So it's a server. Okay. So, however, even though you have very fancy, nice, high-end computer, you cannot use this computer resource without this one. What is this? It's an operating system. Okay? So operating system is a set of group of software between computer resource and a user. User can be human being or it's another computer. Okay? Then this operating system, on top of operating system, finally we have application program. For example, DBMS. Actually, DBMS is the application level. One time, Oracle tried to build operating system plus database operating system, but they failed. Okay, because it's true. DBMS require directly access the computer resource. Sometimes DBMS wanna manage computer resource just like as if the operating system is doing. So they build. Their idea is simple. That makes sense. Why don't we integrate this one and this one? Why? Most of the database system actually is dedicated to the database system. It's not recommended to use database server with application server or web server or other transaction server. No, it's not recommended. Even nobody wants the mix together unless that is a testing server. Okay? Because everybody knows the data itself is very, very important. They don't want to share the computer resource of the database server with the other. So, why don't we integrate? Oracle thought about it and even developed, but it's great. There are a bunch of different reasons, but anyway, DBMS is an application level, which means, so from time to time, I have been asked, so far, still I have a student who asks me, I'd like to be a database administrator. Well, I'm very interested in the database part. I'm expertise on database. How can I prepare such a thing? Do I need to take the certificate exam, like the Oracle certified, whatever, OCP or the CCNP, the network? There is such a the certificate exam. But my answer is, why don't you study operating system first? Why? Without operating system, DBMS, definitely not, because it's application level and computing architecture. Also, network. And also, data structure, algorithm. Your purpose is are fundamental course, basic course for DBMS, database. So database knowledge is usually useless. Okay? Even though you can, if you are lucky, you can get a job as a database administrator. Actually, nobody hired the database administrator as an entry level. Okay? Instead, they try to pick up one of the experienced guy from the group or the project. Okay? Who already developed, who already know about the system, pick up them as a database administrator. But I was lucky. I get a job as a database administrator at the time. I spent 2 or 3 years to learn about it, only for database. But without knowledge of such a thing, especially core courses in database, the computer science, definitely you cannot understand the database itself. So this is the more important, I believe, okay? To be a database administrator. Anyway, the database management system here. Then this is the another computer. Usually we call this one is client. So just like you are doing exercise lab in the one of the computer in the lab, you can submit this query using the SQL plus. For example, this is application program in client side and send to the server. And what happened? Have you ever think about when I enter this query? What's going on? A lot of things. First,
there should be a communication with the server.
it's a connection. First, I log in by providing username and password at ABUC where the connector was here. Connector string, connect the server. Then submit this one. Then what happens? This is SQL language. Anyway, it's a computer language, programming language, but a little bit different from other program languages. Unlike the C, unlike C#, unlike the other core language, whatever, this is the structured query language and also command line interface, which means anyways should be compiled. Right? Computer cannot understand this one. This is for developer, user. Okay? Very close to the human language. However, computer understand only assembly, machine language. So we need to convert. How can we convert? Usually we compile using C compiler, C++ compiler, and Java compiler. But what about the SQL? Do we have compiler?
Yeah, we have.
Yes, we have. That is called interpreter. Interpreter is kind of another type of compiler, line by line. Okay? So it's compiled also. And submit to the database. Database management system has the component. Certain part of the database management system understand this query. Okay? Convert into the something machine understandable code that is called the P code. At that time, it checks whether there exists the employee table, whether there exists the column, also the syntax and the permission and everything. If that is okay, that is stored in P code, and the next job is query processor. Query processor design, as I mentioned many times, best way to access the data. Because DBMS know where data is located. Then sure, first you need to go to the index of this one, then access the database. That will be the best way. Then return the data to the DBMS and go back to the user and list up the data. At that time, let's take a look at this part. Okay. Simply, there are two cases. We have two disk controllers. Okay, two disk controller connected to the operating system. What is the disk controller? What is the controller? managing something. Something means what is something? Device. Peripheral device, any type of device. If you already took the undergraduate course, what is the name of the course that you design the computer, simple computer? Computer architecture? Before that? Yes, there's something. So you actually the code, such a device program, okay? Then connect the mouse and you develop the program. It's a very straightforward way, actually. It's just the definition of input and output value, okay? But this controller knows how to do that. Then this query processor find a way, then interrupt the operating system. Operating system order to return the value of the index or the pointer and address, whatever. Okay, then there are two options, two cases. One is we have this controller A, this controller B, and we have index over here. We have table over here for employee. Okay? And this is one case. Another case is we have index and table in one, this controller C. Okay? The A, B case. Do you think which one is better in terms of performance? To access the same data with the same query. In other words, table and index are separated in case of A. And in case of B, table and index are together in the same controller. Which one is better? B, A, A. Don't worry, I will not just. And B. Why B? Just guess. Why?
Because they are, the linking will be to retrieve the data when we have the tables are indexed together.
I don't get it. Exactly what?
When we have the index and tables together, it will be easy to retrieve the data.
So easy to retrieve the data because they are in the same room. What else? Why you say? In this case, mostly A is better. This controller is kind of room, door. So this is a disk, this is a door. Okay? So whenever we access the data in the table, we need to get first access the index and return what? Pointer of this block, right? Go back and forth, back and forth, back and forth. So if you use index and table in the same room, same hard disk drive with a single door, in and out, in and out, in and out. This hard disk drive itself cannot control the next step, right? This one. At least you should go the disk control, right? However, if you are using the separated index and table, index. So first, what is the index of the 1? 1, there's a pointer, then return, interrupt, and return the pointer of data. At the same time, next index, next index. At the same time, you can access the table. So you can use 2 door and 2 room. That's much faster instead of the same room. Okay? So that is the idea of practical database design. You can physically separate such a data or index that compete with each other. Okay? So for example, it's the same thing in the table only. For example, employee is a very, very important table. So like in terms of ER model, so this is an employee, entity, and all the other tables are connected, the relationship like that. This is called actually star schema model. Okay? Which means whenever you access any data, employee table will be joined. Right? At that time, you better put separate employee to the separate hard disk drive. Okay? And also, update. If a table is updated frequently, you'd better separate that table. If you know specific column, even, you'd better separate such a column. Also, if your data is access only, I have a huge size of the employee table, but this is for data warehousing system, which means it's a lot of batch job. It's not online transfer. We are not going to access only one employee, instead one customer, instead of all entire customer. So at that time you can separate customer table 1, customer table 2, customer table 3, which is called distributed database. Okay, that is called practical database design. How can we decide which one should be separated from the which one? First, you need to analyze your application flow. Okay, so what information do you need? Frequency of select, update, delete, insert. Okay, you need to, for example, insert is one time a day. At that time, don't worry too much because it's just one time. But if the update is frequently ad hoc based happen, you need to separate. Okay, such a thing. You need to specify. Also nowadays, even such a distribution and separation is not good enough. It's too many transactions. Is there any way to speed up? So nowadays, many of the systems use memory database, RAM database. Like most of the laptop, actually, when you purchase the hard disk drive, it's SD, the hard disk drive, right? It's a memory hard disk drive, not physically the disk based. Instead, it's a memory based. It's not volatile. Even though you power off, it will not be gone. Okay? So you can use such a memory base, or even then you can use for hard disk drive. Then you can speed up. Okay? It's a little bit different story, but anyway. So that is the idea of practical database design. Then the tuning. As I said, there are two parts of the tuning SQL. I will little bit talk about the SQL and server tuning the next class before I start the query processing. Okay? So it's not you don't have to submit the homework, but instead you can study by yourself over the weekend. Then I will take your question on Tuesday regarding to the normalization. Okay?